Okay, so for this problem, we want to find the value of dy by dx at the point 1, 1, given that 4xy squared plus 6x squared over y is equal to 10. So we need to do a little bit of work for this one. Now, the question specifically asks for a value of dy by dx, but before we get a value, we need to find an expression, and once we have that expression, then we can substitute our values for x and y into that expression to get the value. Now, before we start to work out our expression though, we need to look at what we have here and go and say, well, we don't like this over y, so let's change that into a power and rewrite this as 4xy squared plus 6x squared y to the minus 1 is equal to 10. Now, for both of these, we have an x times a y squared and an x squared times a y to the minus 1, which are both multiplications or both products, and therefore to differentiate we can use our product rule. Now, we've practiced this quite a few times, so let's see if we can go a little bit faster through the product rule. And if we take our first part of our expression then, and we have our u, which is 4x, which we can differentiate to get 4. We have our v, which is y squared, which if we differentiate that with respect to x, we get 2y times dy by dx. Similar idea then, if we take our other part then, and our u is 6x squared, the differential of that is then 12x, our v is y to the minus 1, and the differential of that with respect to x is minus y to the minus 2 times dy by dx. So we have our different parts. We can apply our product rule for both of these then. For our first one, our product rule, we have our v, which is y squared, times our u dashed, which is 4, plus our u, which is 4x, times our v dashed, 2y times dy by dx. We have a plus, and then we can move to our next expression. And following the same idea with our product rule, so we have a y to the minus 1 times our u dashed, which is 12x plus 6x squared times minus y to the minus 2 times dy by dx. So that's our expression. However, if we look at the original expression, we also have our equals, and the differential of a constant with respect to x is just 0, so we can put 0 there. So let's tidy this up a little bit. So we have 4y squared plus 8xy times dy by dx plus 12x over y minus 6x squared over y squared times dy by dx is equal to 0. Now, normally, if we were just after an expression for dy by dx, it's at this point that we would want to separate our dy by dx terms and then rearrange it so dy by dx is the subject. However, and we could do that with this problem, but we don't need to, because actually we have our values for x and y, so we can substitute in, which is going to make our expression a lot easier. So if we sub x equals 1 and y equals 1, we therefore have 4 plus 8 dy by dx plus 12 minus 6 dy by dx is equal to 0. So that's gotten rid of a lot of the nasty parts of the expression. We have an 8 dy by dx minus 6 dy by dx, which is 2 dy by dx. We have 4 plus 12, which is 16. Move it to the other side, which is minus 16. So finally, dy by dx is just equal to minus 8. Okay, and that's our value for dy by dx at the point 1, 1, given that 4xy squared plus 6x squared over y is equal to 10.